My name is Tim Broom. I'm Chief Engineer for General Motors.
Tell us about the magic that's behind the scene of the new second gen.
Well, the one way I like to talk about magic is to show you what we had in Gen 1 and then how we improved it for Gen 2. So let's start off with going to Gen 1. And what we have over here is some cutaways for Gen 1 so you can kind of see the inside of the transmission and how we made it work. If you look at the back of the engine here, this is what we call a drive unit. And some people generically call it a transmission because it transmits the engine torque into the wheel torque or the battery power into wheel power. Right here you'll see that there is a big motor that we used on Gen 1, and this is what gave all the go and the regeneration power on Gen 1. When you're running on battery only, pretty much this motor did all the work for you, and you can kind of get a visual here as to how big it is. Okay, the old machinist rule of you put your finger there and it's a finger plus a palm on that side right there. If you look inside of there, there's a generator so that when you transitioned off of EV mode into range extended mode, the generator would generate the electricity to feed the motor. And that's the basic Gen 1 concept where it had very good drive quality and it worked very well for the 2011 to 2014 model years. Okay? On Generation 2 we said, well, what could we do fundamentally different? And the big idea was I could then take two of these motor generator combination units and use them better. Okay, so if we come over here to Generation 2, we can kind of see that here's my two motors, okay, but I can use them both at the same time. I can basically say when I'm in EV mode, I'll use two motors at the same time, and these two motors are about the same length of the Generation 1 motor. But when I go to charge sustaining or extended range mode, okay, I can turn one of them into a generator and one of them into a motor or any combination there in between, and I can make everything work more efficiently. So we dropped 100 pounds out of the drive system because we were able to use the motors in a more clever fashion and still get all the performance and the torque that you wanted. And if you look at what we did here, our 0 to 30 time is actually improved 20% with 100 pounds less of motor and drive unit in the system. And then we took the electric range because now the efficiency is better because I can match the two motors' efficiencies, and I can have an optimizer say, here's a way that I run 12% more efficient in the drive unit, giving me that 38 to 53 jump, along with a bigger battery pack. So how did we make all that happen? We've got another display unit over here where I'm going to need an assistant to be my engine. We'll kind of show you how it works. Okay, so we just showed you the cutaway, the components inside the Gen 2 Volt, and now we actually have a working model where you can physically see what happens inside the drive unit as you go from EV to extended range mode. So if you look at the parts inside the drive unit here, here are our two motors, okay, and I'm actually going to rotate these ones to show you how they work together. This chain represents the direct drive that goes to the differential that has the axle coming off going to the wheels. So as you see, the chain move is how the wheels move in the actual vehicle. Up on the front end here is where we hook up the engine, okay? And this crank right here is going to represent the engine with the engine speed and the engine torque. So these three pieces work together to get the result that you want on the axle, and I'll kind of show you how it all works together for you. So if we have a fully charged battery, the engine is off, and we'll just hold that at 0 speed to represent the engine being off right now, and Eric will be my engine today. As I start to accelerate forward, I have both motors spinning where I basically use the battery power and I use the two motors to spin the shafts here to spin the chain and spin the tires. As I go into higher speed, I can split the torque between the two motors to do whatever is most efficient, and that big 12% improvement in efficiency is how we got to that 53-mile EV range. So now that I've driven 53 or 60 miles or whatever I was able to achieve there, I say I need to start the engine to maintain charge sustaining mode. What we'll do is as we're driving down the road, we'll just change the speed of one motor and we'll start spinning the engine relative to the second motor. Now we'll give Eric a little fuel and he'll start providing torque. And for this demonstration, we'll just kind of keep it all the same speed where Eric will spin a constant thing. And you can see that the two motors will work together to have a relative different speed on the chain. So if I actually hold this at 0 speed, you can see that the engine is pretty proportional to the chain speed, and unit B can provide torque in parallel with the engine, giving you that good EV drive feel. If I say that I got to come to a stop while my engine is running because I got to keep the battery charged, I simply spin him backwards, and now you can see that the wheels come to 0 speed. Light changes color from red to green. I say, well, I want to start accelerating again. I start simply just slowing him down, and the engine will provide that speed to the output. If I get up on the highway, I keep the engine at a nice low speed, and I start spinning unit A faster, and I actually get to an overdrive ratio where I can make the whole system work with a very quiet engine, but a very effective, efficient method to have it all work together. Now, this sounds complicated, and it is, but we have computers on the actual Volt that 100 times a second will say, what's this speed, what's this efficiency, how does that compare to this speed and this efficiency, and what's the most efficient way to make it happen, giving you that big jump in EV range of 53 miles, plus 42 miles combined on fuel economy to tie it all together and do it in the most efficient way.